topic of this week is to show you how to compare two means by using t-test and z-test. So what's the differences between the two? T-tests are a statistical way of testing a hypothesis when we do not have the population variance or when the sample size is very small. For example, the N less than 30. If you have a sample less than 30 cases, then you will have to use t-test. Z-tests are a statistical way of testing a null hypothesis when we either know the population variance or we do not know population variance, but the sample size is very big. So this week, I ask you to use the GSS 2006 data that is fulfill the requirement of using z-test. But later, I'm going to show you a chart. In fact, both t-test and z-test are okay if your sample size reach to a certain level. So there are three types of t-test and three types of z-test. We have independent sample z-test or t-test, one sample t-test, or pair sample t-test. The independent sample t-test basically, or z-test, basically is compare the group average or group mean between two different groups. So for example, to compare the group means between men and women or two different racial groups, say like blacks and Hispanics, or two regions or two states like Texas and California, then you have to use independent samples t-test. The second type of t-test or z-test is one sample t-test. The one sample test basically is to compare the group means of a sample and its populations. So for example, if you want to compare the SAT mean score for Jefferson County students and the SAT mean score of Texas at the state level or even the United States, because Jefferson County is in Texas state, so you will adopt the one sample test. The third type of test is paired sample t-test or z-test. So it is compare the same group A mean in time 1 and time 2. So this kind of a test normally is adopted for experimental study to test if a certain experiment is effective before and after. So for example, you want to test the mean SAT score for the same group, like the level, the SAT score in Jefferson County in January and the same population in May, then that will be the case to use the pair sample test. So how do we decide, whether t-test or z-test is appropriate for our research purpose? Number one is the populations, is the sample size. Okay, if the sample size is greater than 30, then yes. When the sample size is larger enough, if the population variance is unknown, but you have a large sample size, then either z-test or t-test is okay. So whether you know or not, as far as you want to make sure the sample size is large enough. And that is because when you have a very big sample size, there's enough cases within the sample So that means there's enough variation, in big group. But if the sample size is not greater than 30, then you want to make sure that the population variance is known or unknown. If you don't know the population variance, then you need to use t-test. Otherwise, you use z-test. Next, I want to briefly talk about hypothesis testing, the fundamental idea and the basic concept. Here, I can use an example to explain the fundamentals of hypothesis testing. Say there's a person is on trial for a criminal offense, and the judge needs to provide a verdict on his case. Now, there are 4 possible combinations in such a case. If the person is innocent and the judge say he's innocent, then there's no error. Another situation is if the person is guilty and the judge thinks that he's guilty, there's no error either. The only 2 possible type of error could happen is either the verdict is against the person while he was innocent, then that will be the type 1 error, or when the verdict is in favor of the person while he was guilty, and that will be the type 2 error. So according to the presumption of innocence, the person is considered innocent until proven guilty. That means the judge must find evidence which convince him beyond a reasonable doubt. And this beyond the reasonable doubt can be understood as probability, which is the probabilities of error. Okay, so the probability, more specifically, the probability that judge decide guilty but person is innocent, which is the type 1 error, or the probability of type 2 error. And they hope that this kind of a probability can be very small so that we have enough confidence to prove that either innocence or guilty is true. So use this example to look at the hypothesis testing. It's very similar logic. We consider the null hypothesis to be true until we find strong evidence against it. Then we will accept the alternative hypothesis, or we can call that research hypothesis. So the null is H0, and the alternative or research hypothesis is H1. We also determine the significance level, and the significance level is alpha value, and which can be understood as a probability. And alpha is also the critical value that representing a critical zone that we should reject the hypothesis. So if the probability of sampling error, which is similar to the probability we said earlier that the judge decide guilty but person is innocent, the type 1 error, we want to make sure this type 1 error and type 2 error can be as small as possible so that we can reject the null and support our research hypothesis. So if alpha is smaller, then we will have a higher level of confidence in this case. Okay, so for example, if the confidence interval is 95%, then the alpha is equals to 0.05. And that's where that alpha value coming from. It's based on the confidence interval. So compare with 99% of a confidence interval when alpha is 0.01, then we can say, that's why I say when alpha is smaller, then you have a higher level of confidence. So when we do the hypothesis testing, we follow 4 steps. Number 1, you have to set the null hypothesis and the alternative or research hypothesis, H0 and H1. Second step, you set the significant level, which means you have to decide where or how big the alpha value should be. So if you set the alpha equals to 0.1, that means the confidence interval will be set at 90%. Or you can set it at 95% or 99% or 99.9%, etc. Normally, when the sample size is very small, then the confidence interval can allow to be lower. So for example, if you have an experimental study and then only have 30 cases or less, or say 25 cases, then a lot of psychological research consider there may not have enough variance in the sample, then 90% of a confidence interval is acceptable sometimes. But for most of the social science research, now 95% of a confidence interval is a standard for most of the study. That includes educational study, political science, sociology, social sciences in general. For a demography study, in the social demography study, because most of the study use a larger national or even international representative data, such as like a census, then the sample size will be very big. And in that kind of study, you will see 99% or even 99.9% of a confidence interval is very commonly used. So in that case, if your confidence interval set to be 99.9%, then your alpha value will be 0.001. Okay. The third step is to compute the test statistics, which is the p-value. So confidence interval and alpha is a standard that you set for your study. And then based on the data, you want to know whether or not the statistics calculation, the test score shows supportive outcome, right? So the p-value is the criteria for us to make a decision. So if the confidence interval is equals to 95%, the p-value should be less than or equals to 0.05, which we call the statistical significance, and then be able to reject the null. So after the computation, after you generate the p-value, which the software will generate for you, you can make a decision. So for example, if the p-value less than 0.05, we can reject the null hypothesis and the alternative hypothesis is supported. Here I want to show you, the pre-assumption, the assumption of a normality, compared with this hypothesis testing procedure for your assignment. For both the t-test and z-test, the assumption of a normality should be met for hypothesis testing. So if the sample is not normally distributed, the statistical result is biased. And you cannot use it, to interpret or to represent the whole population. And this assumption is especially important, like we said earlier, for small sample size. So if the n number less than 30, then the pretest of normality and homogeneity of variance should be screened before hypothesis testing. If the sample size is large enough, then you can ignore both assumptions, which is okay. So this is why, for assignment 3, with the GSS data, we have a sample size of 1500s. It is okay to choose either the t-test or z-test, but I would like you to provide an explanation and judgment to show me why you think both are okay, or why one is not okay, and what's the differences. So as mentioned, the alpha shows the significance level. So this red line and the yellow highlight area, this whole area behind the red line is alpha value. And p-value basically is a statistical test that we calculated based on the data. So critical value is kind of like a standard you set after consider what level of confidence you want to adopt. So once you set the confidence interval, we know where that critical value is. And then you compare the p-value with that critical value. So when the p-value less than 0.05, then you can see this blue line was cut behind, this critical value is less than critical value, which means the sampling error was not fall within the zone of a confidence interval. Then it is okay to reject the null hypothesis, which means that we have 95% or higher of a confidence that we can reject the null. But if the p-value greater than 0.05, then that means the sampling error fall within the zone of a confidence interval, then that means we don't have enough confidence, then we cannot reject the null. So the concept is very simple. But of course, here I want to remind you the chart that I provide here is a one-tailed test. If this is a two-tailed test, then it will be different, because one-tailed test basically is a directional hypothesis, which means the directions between independent and dependent variable is null. So your hypothesis will be like, I hypothesis that one is larger than the other, or one group A mean will be greater than group B, the group mean. Let me rephrase that again. If this is a one-tailed test, that means, say like you hypothesize that the group mean for A will be greater than group mean for B, or differently. So that shows that one group is greater than the other, then that's a directional hypothesis. But if this is a non-directional hypothesis, then that will be two-tailed test, because the sampling error will fall on both tail. Okay, so the confidence interval 1 minus alpha will fall in the center part, and on both sides, the critical value alpha will be divided by 2. So 1 on one side and half on the other side. So both zone, this red zone, will be the rejection zone. And that would be what we call the two-tailed test, or non-directional hypothesis. So for a two-tailed test, the hypothesis will be something like female will score significantly different than males on IQ score. So there's no prediction on the direction of a hypothesis, either male is higher or female is higher. No, it just say that they're different. if that's the type of hypothesis that we proposed, then we should adopt the two-tailed test, because the rejection zone will fall on both sides. And that's it. So for the assignment, I would suggest you to do a two-tailed test instead of a one-tailed test. So when you form your hypothesis, just form as the way on this slides, just form your hypothesis to be male groups is different from female groups. But when you test for sexism, definitely the differences, you have to look at the group average, right? You want to see the mean score for women. Is it really lower than men on their socioeconomic status? You can still do the two-tailed test by looking at the mean score and to see if your hypothesis on sexism in year 2006 is supported or not. Okay.